In this video, we're going to do both the sections 2.3 and 2.5 together. In the section 2.3, it's only one question. It's going to take just a second to explain. So the only question from 2.3, so say if we just have some graph, let's have this. Okay, so a graph that looks just like this. There's a couple of things on here that we're going to want to point out. Something called, what does it mean to be constant? What does it mean to be increasing? Decreasing. And then also just from looking at a graph, how can we find the domain? And then how can we find the range? So these 5 things. So let's talk about the first 3 first: constant, increasing, and decreasing. So to find what to point these out on the graph, we need to look from left to right and see how the graph is moving. So say if we move from this side of the paper to this side of the paper, here the graph moves up, moves down, moves up, is flat, and then moves up again. So that's how we're going to figure out what constant, increasing, or decreasing is. And just like how it sounds constant, just means the graph isn't changing. So it's going to be a horizontal line. So let's just make up some numbers. Let's say this is like an x value of 3. This is an x value of 5. Over here, let's call this 1. This could be minus 6. Okay, yeah, that's all we need. So when we're talking about constant, increasing, and decreasing, we're talking about what are the x values that this graph is constant at. So what are the x values where this graph is just moving horizontal? Well, the graph's not horizontal here. It's not here, here, here. The only time it's horizontal is right here. This is where the graph is constant. And it's constant from an x value of 3 up to an x value of 5. So we're going to write the interval, 3, 5. And so for these first, you might be thinking, well, there's closed dots here. Why aren't we putting brackets instead of parentheses like we are here? Whenever you're dealing with constant, increasing, and decreasing, no matter what, it's always going to be parentheses. So the only time that we're going to need brackets are brackets may come into play or the domain and range. But for these first 3, it's always going to be parentheses. Okay, so increasing is just what it sounds. It's when the graph moves up. So as we look from left to right, the graph moving up. So if we look over here, the graph moves up, moves up, moves up. So it stops moving up here, then we move down. Then we move up again right here, so we're increasing again on this section, but it's constant, so we're not increasing there. But then it moves up again, so it's increasing here. So all those x values, so you see this graph is just moving down and down and down and down forever. So it's, as you see, if we look from left to right, it's just always increasing from this all the way over here. So from minus infinity up to minus 6, that's the first section. So we're increasing there. But then we decrease, but then we're going to increase again. So we're saying that's from 1 to 3. So put a union symbol, 1 to 3. So we're increasing on this section, but then we're constant again, but then again we're increasing over here. So from 5 to infinity. Okay. Now decreasing is just when the graph moves down. So if we look from left to right, we're moving up here, we're moving up, then we move down. So we're decreasing on this section from minus 6 to 1. Then we're increasing again, constant, increasing. So that's it. So we're constant on this section, we're increasing on these 3 sections, and we're decreasing on this section. All right, so let's talk about the what the domain is. So the domain is all the x values. And so what this means is, you know, for example, here's the x value of minus 6. We get this point on the graph. Here's an x value right here. We get this point on the graph. Here's an x value right here. This is the point we get on the graph. The domain is all the x values that have points on the graph, meaning, so for example, this point right here, 1, this is in the domain because we have a point on the graph. And if you look at all these x values, we always have points on the graph. So even right here at 3, so circle means we're not that number, but we have a point up here. So 3 is actually in the domain. The only time that we're going to have something that's not, so just let's finish up this problem, we'll talk about like another scenario. If you look at, so every one of these x values, every one you can think of, you can find a point on the graph for it. So that means the domain is going to be minus infinity all the way up to infinity. So every x value has a point on the graph. Now a range is all the y values. So an easy way to find the range is, so here's the y-axis. If you can draw a horizontal line and touch a point on the graph, then that means that y value is in the range. For example, let's just call this minus 10. We can draw a horizontal line through minus 10, and we touch the graph right here. So that means minus 10 is in the range. And if you look at this graph in particular, every y value has a point on this graph. So for example, say here's minus 8. Draw a line across, touches the graph right here, minus 8 does. So every time we go lower and lower and lower, we're for sure going to touch this part. But you see, every time we draw this horizontal line, we're always touching lines on this graph. So that means in this situation as well, the range is going to be minus infinity to infinity. So let's just do a quick example that shows when the domain won't be this and when the range won't be that. So say if we have something like, okay, so let's call this point minus 5. This could be minus 2. Here's 1, and then 3. So let's talk about just the domain for this graph. So the domain, all the x values. Well, so here's minus 5. We plug in minus 5, we get this number. So minus 5 is in the domain. Again, if we plug in all these x values right here, we get all of these y values. So all these y values from minus 5 to minus 2 are in the domain. Because at minus 2, you plug that in and you get this number. So we keep plugging in these x values, we get these points, so these are all good. So from minus 5 up to 1 is good. Oh, but for example, to the left of minus 5, there's no graph over here. So nothing to the left of minus 5 is in the domain. 1's in the domain, we have that. But again, nothing right in here. So we skip from 1 to 3. But then from 3 on, this is in the domain. So like we said, we have from minus 5 all the way up to 1. Again, because all of these x values have points on a graph. Then we skip from 1 to 3, but then we go from 3 all the way to infinity. And we have 3 with a parenthesis, and that's because we can't plug in 3. When we plug in 3, we get this open circle. So we can't plug in 3, but we can plug in numbers just to the right of 3, and we get these points. So now the range for this graph, let's call this point right here 2, call this one 4, and down here, -5. So the range is all the y values. If you look down here, if we draw these horizontal lines, we never touch the graph. So none of these y values down here are in the range. The first y value is this minus 5. This is the first time where we draw a horizontal line and we touch a graph. So for the range, and we have a bracket because it's a closed dot. So we're going to start at minus 5. And so we can keep going up, we keep touching, we keep touching, we keep touching, but then we stop right here at 2. So it's going to stop at 2, and then we skip this section. But then at 4, we're good, and then this is going to keep going up. So if we keep drawing lines, we're going to keep touching this graph. So then from 4 to infinity is going to finish off the range. Okay, so that's basically it from the section 2.3. So let's do the 2.5 questions. So the first thing we're going to talk about is the whole goal of this section is to graph a function that looks like this. Maybe like so 2x minus 1 squared plus 3. And so we're going to do that by graphing this equation in steps. So we'll explain how to figure out these steps in a second, but the first thing that we would graph is just x squared. The second thing we're going to graph is going to be x minus 1 squared. The third thing that we're going to graph is going to be 2 times x minus 1 squared. And then the fourth thing that we would graph for this problem is going to be 2x minus 1 squared plus 3. So if you see, this graph gets more and more complex, and then when we're done, we get to the one that we want. So there's this one, a little bit more, and we're just adding these pieces as we go on. So here, like, we added this minus 1, here we added this 2, and then here we added this 3. And so then what we're going to do for this is we'll see that all we need to able to graph something like this, all we need is just the graph for this one. And once we have the graph for x squared, this little minus 1 is going to tell us to do something, this 2 is going to tell us to do something, and this 3 is going to tell us to do something. But the only graph that we're really going to need to do all this is just x squared. So before we get into why that's true, we're just going to start with 3 properties. Let's put this is the first one over here. So say if we have a graph f of x, and then what we want is now to find the graph of f of x plus some number. So what this is going to do is then, so say, if, so I'll write what this means, and then we'll do it with a quick example. What this means is we're going to add, so this can actually be a plus or minus. So if this sign is a plus, this means that we're going to add c to all the y values. And if it's a minus sign, we're going to subtract c to all the y values. So what do I mean by that? Let's say if we just have this graph right here. Okay, let's put some points on this graph. Let's say this is the point 0, 1. This is the point 3, 6. And this is the point -2, 4. Okay, now let's call this graph f of x. Now let's say if we want to graph f of x plus 2. Okay, so this is f of x plus 2. We see over here, if we graph f of x plus or minus a number, so if we're adding a number, we're just adding that number to all the y values. So what that means is, well, if we're adding 2 and we want to graph this, that means all these y values, this 4, this 1, this 6, we're going to add 2 to it. So instead of having this be 0, 1, now it's going to be 0, 3. Instead of this being 3, 6, now it's going to be 3, 8. Instead of this being -2, 4, it's going to be -2, 6. And then we just connect the dots with the same shape. So again, all we're doing, if we have an equation and we're adding a number to the outside of the equation like this, so just like, we have our equation, we just add 2 to it. So how is that going to change the graph? Well, that's going to add 2 to all the y values. So we added 2 to this 4, it became 6. We added 2 to this 1, it became 3. And we added 2 to this 6, it became 8. And so say if this was a minus sign, a -2, we would just subtract 2 from this one, subtract 2 from this one, and then subtract 2 from this one. So this is the first, all these things are called transformations. So this is the first transformation we're going to do, is when we add or subtract a number directly to, or on the outside of our the function that we're dealing with. Okay, so the next transformation that we need to talk about, so again, say if we have some equation f of x, and then now what we want to find is just some number times f of x. And so what this is going to do is you take all the y values and multiply them by a. Okay, so let's do another example of that. Let's say if we have some graph here. Okay, let's put a couple points on here. Let's say if this is the point -1, 1. This could be the point 1, let's do 1, 0. And this could be the point 2, -1. Okay, so we have these 3 points, and we'll call this f of x. Now let's say we want to find the graph of -2 times f of x. All right, so here that a is a -2. So this is just some number, -2, and we're multiplying it by f of x. So it's just like this. So here's our f of x, we're multiplying it by a number. And this is telling us, okay, well, we take all of our y values and we're multiplying them by that number. So let's take all of our y values here, this 1, this 0, this -2, and we're going to multiply it by that number. So then what's that, how's that going to change? Well, here's this point, -1, 1. If we multiply this 1 by a -2, it turns into -2. So now that point's going to be down here, -1, -2. Again, because 1 times -2 is -2. This point is 0. If we multiply by 0, it's not going to change. So that point's going to stay still at 1, 0. This point is -1. If we do -2 times -1, we get +2. So then that point's going to move up here to 2, 2. But if you see what's happening is, well, 1, we're multiplying that, so that number is changing. But when we multiply by a negative, you see up here, it took this point and brought it to the bottom, took this point and brought it to the top. So really what's happening is if we multiply this point by a minus 2, it's going to come down somewhere over here. So basically when we multiply by a minus, the whole graph gets flipped upside down. So instead of looking like this, now it's going to look like, so we'll have, if we were to multiply every one of these points by a minus 2, so just say to convince yourself more, let's call this point right here about, minus 4, minus 2. Okay, so if we multiply this one by minus 2, that's going to turn into positive 4, which is like somewhere up over here. So you see at minus 4, now we're going to be at minus 4, positive 4. So if you were just going to pick more points, you'd see that it's going to match this graph. And so all we did here is we took all of our y values and just multiplied it by this minus 2. Okay, let's talk about the last transformation. So this one, we have our f of x, and we want to turn it into this, x plus minus a number. So this is a little bit different from the first one. The first one we were adding a number to the outside, now we're adding this number or subtracting a number onto the inside. And so here, if we have a plus sign, this tells us that we're going to subtract this b from all the x values. So it's the opposite. With a plus sign, we're going to subtract, and just like that sort of stays the same. With a minus sign, we're going to add. So what do we mean by that? Again, let's just draw another example. Say if we have, how about something that looks like this. Here's the point minus 1, 8. Here's the point 1, 0. And then here's the point minus 7, 0. Call this f of x. Now let's say we want to find the graph of f of x minus 4. Okay, so that's of this form. We have x minus a number. When we see it's x minus a number, we're going to take that number and we're going to add it to all of our x values. So that we're doing x minus 4. So we're going to take 4 and add it to all the x values. So here's a graph. So this x value is a minus 1. If we add 4 to it, it turns into a positive 3. So that point's going to move over here to 3. Sorry, this is a minus 8. So we add 4 to that, it's going to turn into a positive 3. So we'll have 3 minus 8. This x value is minus 7. We add 4 to it, it's going to turn into a minus 3. So now it's going to be at minus 3, 0. Notice how the y's aren't changing here. It's only the x values. We're only adding or subtracting to the x value. So the y value needs to stay the same. Here we add 4 to this 1, turns into a 5. So it's going to be a 5, 0. And connect the dots, and then that'll be it for this one. Okay, so with these 3 rules in mind, now let's go back to that first problem that we talked about, or just briefly mentioned at the beginning of class. So we have, say we want to graph this equation. F of x is equal to 2x minus 3 squared plus 1. So we're going to do this through something called transformations, and also something called the parent function. So let's start with the parent function. So how to find the parent function is we look at our example, and we're going to get rid of every single number that is not an exponent, but not a variable. So we're not going to get rid of our x, but we're going to get rid of every number that's not an exponent. So we're going to get rid of this 2, get rid of this minus 3, and we're going to get rid of this 1. And if you do that, all you're going to have left with is x to the power of 2. So our parent function is going to be x to the power of 2. And so now we need to find our first transformation. So in the first transformation, we need to find what's happening closest to the x, and then we move out away from that. So for example, the closest thing to this x is this x minus 3. So the x minus 3, that's going to be the first transformation. And so now you see here, this is x minus a number. So this is sort of like the last one we just talked about. So this means we're going to add 3 to all the x values. So now our next transformation, the next closest thing is this 2 being multiplied by it. So the second thing we need to do is 2 times x minus 3 squared. So now you see this 2 here is being multiplied on the outside of everything. It's not being multiplied directly to the x. This is multiplied on the outside of everything. So you can see here, this is sort of like of the form x minus 3. This is a different, let's call this just g or something, because f is this. So this is now, like, say, of the form 2g of x. So this 2 is multiplied on the outside. So this is sort of like the last transformation we talked about. This is the second one we talked about. The third thing then is going to be adding this 1 at the very end. So 2 x minus 3 squared plus 1. Now this is kind of the form, g of x plus 1. So this g doesn't mean anything in particular. This is just sort of illustrating what's going on. This minus 3, that kind of acts like this one, which was the third one we did. This 2 right here sort of is like this, so it's the second one we did. And this plus 1 is related to this. This is the very first one we did. So now all we need to do is start by graphing this parent function, and then we're going to apply all those transformation rules, like, for example, what this minus 3 does, then what this 2 does, and then what this 1 does, to just the graph of x squared. So let's start with the graph of x squared. So this is one you need to have memorized. It just is a parabola. And so we need to figure out some points on the graph. Say if we plug in 0, we get 0 squared, which is 0, so the point 0, 0 is on this graph. Okay, if you plug in 1, you get 1 squared, which is 1, so the point 1, 1 is on this graph. If you plug in minus 1 to x squared, you get, again, minus 1 squared, which is positive 1, so minus 1, 1 is on the graph. So here's 3 points on this graph, and now let's use all these rules then. So here's x squared. So let's move on to the next graph, which is going to be this one, x minus 3 squared. Okay, so what happens when we said a second ago if you do x minus 3? So this minus 3 is being directly to the x. And so that means if it's a minus, you're going to add to the x values. If this was a plus, you would subtract from the x values. So since we're doing minus 3 to the x values, so we're going to add 3 to all of our x values up here. So we're going to add 3 to this minus 1. It's going to turn into a 2. 2, 1. We're going to add 3 to this one. It'll turn into a 3. We're going to add 3 to this one, so it's going to turn into 4. Okay, and let's connect those dots. Okay, so that takes care of the first one, the x minus 3. So this next one is this 2. Let's draw another graph. So if you remember, when we have a 2 on the outside of everything multiplying, we're going to take all of our y's and multiply it by that number. So here's a y value of 0. Multiply it by 2, it stays 0. So we still have that point at 3, 0. Here's a y value of 1. You multiply that by 2, it turns into 2. So we're going to have this point up here, which is 2, 2. Here's a y value of 1. We multiply it by 2, it turns into a 2. So then we're going to have that point 4, 2. Then we connect those dots. Okay, and then the last, so here's 2x minus 3 squared. And so now our last one, which is going to be 2x minus 3 squared plus 1. So now we're doing a plus 1 on the outside of everything. And this means we're going to add 1 to all of our y values. So we add 1 to this y value, we're going to get 3, 1. We add 1 to this y value, we're going to get 2, 3. And then we add 1 to this y value, we're going to get 4, 3. All right, and so then here's the graph of the last one. And this is the graph that we were looking for. So in order to graph this was the original problem, just graph this function. In order to graph this, we're going to have to go through all these steps. So we graph this one, then this one, and this one, and this one. But by the time we get to this one, that's the one that we were looking to graph. Okay, so let's do one more example. So let's do that same thing to the square root of, what's the one from the homework? Okay, let's do x plus 3 plus 2. Okay, so let's start just like last time with the parent function. So the parent function, like we said last time, is just we get rid of every number that's not an exponent. So we're going to get rid of this 3 and get rid of this 2, and we're just left with square root of x. So in the first transformation, the first thing that's happening to x is this plus 3. And then the second thing that's happening to this whole thing is the plus 2 at the very end. Okay, so let's start with the parent function, just graphing square root of x. So for this one, again, you just need to have it memorized. And so it starts at the origin, and it makes this shape. And there's no points back here. So it just starts right here and does this. Okay, so now let's put some points on it. So if you plug in 0, you get the... So let's talk about how... Let's show that work for that. Like, we'll make an xy table. So this is for y... let's put the square root of x here. So if we plug in 0, we get the square root of 0, which is 0. So that's why the point 0, 0 is on here. Let's say if we plug in the point 4. The square root of 4 is 2. So then we get this point 4, 2. Say if we plug in 9, the square root of 9 is 3. So then we get this point 9, 3. Okay, so here's square root of x. We've got some points on it. Okay, so let's move on to the first transformation, which is square root of x plus 3. Okay, so what are we doing here? We're adding a 3 directly to the x. So that means we're going to subtract 3 from all the x values. So we subtract 3 from the 0, we get minus 3. Subtract 3 from the 4, we're going to get 1. Subtract 3 from the 9, and we're going to get 6. And the y values don't change. We still keep that to be 0, that to be 2, and that to be 3. Okay, so then we connect these dots. So now we move on to the last one. Okay, so now we're adding 2 on the outside. Adding 2 means everything moves upward. So we're taking 2 and adding it all to the y values. So add 2 to this 0 becomes positive 2. So minus 3, 2. Add 2 to this, it's going to become 4. So 1, 4. Add 2 to this and you get 5. So 6, 5. Okay, and so then this would be the final graph for this problem.